Alright everybody, the last section, 11.5, and here I wrote the binomial theorem. So when you have some binomial to a power n, it's going to equal the sum from j equals 0 to n of n choose j times x to the n minus j times a to the j. And when you write this out, it's going to be plugging in 0 for j, so the n choose 0, x to the n times a to the 0, plus n choose 1 times x to the n minus 1 to the a, to the a, plus n choose 2, so here j is 2, x to the n minus 2 times a to the 2, plus dot dot dot, and you'll continue until you get to n, so you'll have n choose n times x to the n minus n times a to the n. And just some things that kind of always help keep me sane when I'm going through this is, even though we're technically not allowed to add the exponents for the x to the n and a to the 0, or x to the n minus 1 and a to the 1, but one thing that you can do is when you do add those exponents, it should always equal the exponent or the power that you're raising the binomial to. So n plus 0 is n minus 1 plus 1 is still n minus 2 plus 2 is still n. So this is going to be something that kind of just helps you keep track of everything. And of course, instead of plugging the n choose j into your calculator, you may want to use the Pascal's triangle to figure out the binomial coefficients. So when we look at expanding w plus 3q to the fifth, let's write this out using the summation notation. It's going to be j equals 0 to 5 of 5 choose j times, instead of it being x, it's going to be w to the 5 minus j, and then instead of it being a, it'll be 3q. And I'll be sure to want to put this in parentheses, because when I'm raising it into powers of j, I want to make sure that it's the whole quantity raised to that power. And so let's go ahead and expand this. So we'll have 5 choose 0, w to the 5 minus 0, so to the fifth, times 3q to the 0, which will just be 1. But let's just write it all out. Going to the next term, 5 choose 1, w to the 5 minus 1 times 3q to the 1, because j is 1, but also notice 4 plus 1 is 5, plus 5 choose 2, w to the 3 times 3q to the second, plus 5 choose 3 times w to the 2, because 5 minus 3, times 3q to the 3, because j is 3, plus 5 choose 4, w to the 1 times 3q to the 4, plus 5 choose 5, w to the 0, 3q to the fifth. Alright, so another cool thing that you probably noticed as we were writing this all out is, and similar to when we just expand something small and we rewrite our the exponents in decreasing order, you'll see that this w to the fifth, it decreases by 1 for each term, and the second term of our expansion, 3q, its exponents are increasing by 1. All the while, the sum of those is always the power that we're raising our binomial to. So all that's left is just to rely on Pascal's triangle, and let's see, I'm going to squeeze it in up here. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then lastly 1, 5, 10, 10, 5, and 1. Ran out of space. So what that's telling us is that in this entry it's 5, choose 0, and so that's going to be 1. So we really just have, let's slow down, this is 1, and then w to the 5th is there, 3q to the 0 is 1, so we'll just have w to the 5th plus 5 choose 1 is 5, and we have 3 q to the 1, so we have 5 times 3, 15, and then it'll be w to the 4th, q to the 1, plus 5 choose 2 will be 10, and then we have a 3 squared, so 10 times 9 is 90, w cubed and q squared, plus 5 choose 3 is 10, 10 times 3 cubed is 27, so that's 270, w squared q cubed, plus 5 choose 4, which is 5, times 3 to the 4th, 81, 5 times 81 is 405, and then we'll have w and then q to the 4th. And then lastly, plus 5 choose 5, which is our 1, w to the 0 is gone, and 3 to the 5th is 243, q to the 5th. And this is our final answer. Alright, so doing this whole entire one can be pretty tedious. That's why in the next problem I change it up to be just find the first 5 terms, and then I can also in later problems just ask you to identify one term of that expansion. Alright, so I'll see you in a couple more videos.